everybody gotta do?
What?
Hi friends, my name is Chandu. Now in this video, I am going to show you how to design a differential operational amplifier using multisim. In the before video, we have seen the integration amplifier, how it works. Now the differential amplifier, the difference between them is here we replace the capacitor with the resistor and resistor with the capacitor, like the way as it is shown here. It is replaced with resistor and it is replaced with capacitor, and input is given here. Now we will see how the differential amplifier works. Open the multisim. Launch. Now open the operational amplifier. Place component in groups, all families, all groups. Here select OP Amp and select AM14 and click OK and place it on the board. Now we want a resistor and a capacitor. Take them from basics. LC resistor, LC resistor. I think here we want capacitor in place of, and we also want a capacitor. Place it here, and we also want VDD and VCC saturation voltages, that is VCC and VDD, plus and minus 12 volts, and VDD. Now I am closing it. We also want input, so the function, I am using function generator for input, and to measure the output I am using oscilloscope. Now here you see the circuit diagram. Connect with a resistor here. Now take a resistor and connect it with resistor. Connect the resistor. And from the resistor to the negative input. Now to the negative input, and here instead of resistor we have to keep capacitor, so the capacitor is kept. I link it with a resistor, and for that we have to give the power supply, so I am giving it and come to the ground. So we need a ground in the families. Sources we will see ground, here it is. Click on OK. Close. Come to ground, and we also need to measure the input, so I am placing one here and one at output. 1, 2, and both minus are to the ground. Here is to the ground, it is also to the ground. And now we have constructed, I think it is also should be to the ground. Yes, the plus one is also ground, so the plus one is also ground. We have grounded all the things, and the circuit is over, I think. Now we have to change the values. Here VCC 12 volts, okay, and VDD is minus 12 volts. VDD to the 4 pin. Here we connected, all the connections are over. I think now I'm giving frequency as 100 Hz and amplitude as 1, and opening the multimeter, running it. Here you see the outputs. Now change the color of the output. Properties, net color, select the output required, apply, click on OK. Simulation is running, so we have to restart it, stop it, and restart again. Reversing the color for better view. Changing the scale. Changing the capacitance. Without put this amplified very much. I'm changing the connection for here. Stop it and using the connection. I'm connecting A to before capacitor. Opening it, running. You can see that the sine wave is shifted, differentiated. I am zooming in. Here you see that the phase of the sine wave is shifted to opposite side, means differentiation of sine is cos, like that. Here the angle is shifted between them. You can see that there is a phase difference between them, so the given wave is integrated. We will change to the square wave. What happens to the output, we will see it now. You can see that the output is not clear. It is steps functions, means the output is response at only one point and highest peak at a high peak. The opposite sides is response and closes. If I change the value of the capacitor, I am increasing the time. Here you can see that how the waves are formed by the use of capacitor. It is changed, like it is decreasing. I will increase the scale. You can see the better wave. Here you can see that the wave is decreasing due to the capacitor, and the waves are formed like this. It's nice to see. Thank you for watching the video.